So our topic for today is all about the operations on radical expressions. First, we have addition and subtraction of radicals. Addition and subtraction of radicals.
Adding and subtracting radicals are just like adding and subtracting algebraic expressions. That is, if in algebraic expressions, we only add or subtract similar or like terms. Then, if we add or subtract radical expressions, we only add or subtract similar or like radicals.
We can add or subtract the radicals if the index and radicand are like or the same. So we have an example, cube root of 5. 3 is called the index, and 5 is called the radicand. Examples. So we have number 1, square root of 2, 8 square root of 2, 6 square root of 2, 5 square root of 2. Our index here is 2, and our radicand is also 2. They have same index and same radicand. That's why our example number 1 is like radicals. Okay, number 2. 5 cube root of x. 7 cube root of x. Cube root of x. And 10 cube root of x. This is also same index, and that is 3, and same radicand, and that is x. Same radicand and same index, that's why our example is like radicals.
Okay, let us perform the indicated operations. Example number 1. We have 6 square root of 3 plus 2 square root of 3 minus 4 square root of 3. We can combine the coefficients and affix the common radicals. So the coefficients are 6, then plus 2 minus 4. The affix common radical is square root of 3. Then we need to combine 6 plus 2 is 8. Minus 4 is 4 square root of 3. Number 2, we have 8 square root of 7 minus 4 square root of 7 plus 2 square root of 7. So we can combine the coefficient. So the coefficients are 8 minus 4 plus 2, and the common radicals is square root of 7. So 8 minus 4 is 4 plus 2 is 6. That's why our answer is 6 square root of 7.
Okay, let us have the next example, number 3. So we have 4 square root of 5 minus 2 square root of 5 plus 4 square root of 3 minus square root of 3. So we have different radicals. Now we can combine the same radicals. So the coefficient of square root of 5 are 4 minus 2. Then affix the common radical, and that is square root of 5. The other one, the coefficients are 4 minus 1. Affix the common radicals, and that is square root of 3. Then we can combine. 4 minus 2 is equal to 2. Then affix the common radicals, square root of 5. And 4 minus 1 is 3. That's why the answer is 3 square root of 3. So our answer for this example is 2 square root of 5 plus 3 square root of 3. Okay, the fourth example. So we have
5 cube root of 2 minus 2 cube root of 2 plus 2 square root of 2 plus square root of 2. So we can combine the same radicals again. So the coefficients of 5 minus 2, then affix the common radicals, and that is cube root of 2. Plus, the coefficients are 2 plus 1, then affix the common radicals, and that is square root of 2. So we can combine now. 5 minus 2 is 3 cube root of 2, and the other one plus 3 square root of 2. And that is the final answer.
Although there are radicals that may seem dissimilar at first, but examining them closely will enable you to transform them so that they become similar radicals. Let us consider square root of 5 and square root of 20. Square root of 45, we need to get the two factors that the one factor have perfect square, and that is 9 times 5. So square root of 9 is 3 square root of 5. The other one, square root of 20, two factors that the one factor has a perfect square, and that is 4 times 5. Then square root of 4 is 2. That's why we have 2 square root of 5. So this 2 has a same radicals. Okay, let's have number 5. We have square root of 8 plus square root of 18. So the factors of square root of 8 is 4 times 2. And then the factors of square root of 18 is 9 times 2. Because 4 has a perfect square and also 9 has a perfect square. So the square root of 4 is 2. Then we have 2 square root of 2. Then the next one is square root of 9 is 3. Then we have 3 square root of 2. Then we have to combine this. So we have the same radicand. And then we have 2 plus 3 is equivalent of 5. So we have the answer of 5 square root of 2. Okay, next example. Number 6. So we have square root of 32 plus square root of 18 minus square root of 50 plus square root of 8. The factors are, so in square root of 32, we have 16 times 2. In 18 is 9 times 2. Minus, in 50, we have the factors are 25 times 2. And in 8 is 4 times 2. So we have the perfect square. Use 16, 9, 25, and 4 has a perfect square. So square root of 16 is 4, then square root of 2, the radicand, plus square root of 9 is 3. So we have 3 square root of 2. Minus the square root of 25 is 5 square root of 2. And then we have square root of 4 is 2 square root of 2. So we have the same radicand. So we can combine this now. So we have 4. So we have 4 plus 3 minus 5 plus 2. And the same radicand is square root of 2. So we're going to solve that. 4 plus 3 is 7. So 7 minus 5 is 2. And then 2 plus 2, it become 4. So 4 square root of 2 is the final answer. So do you have any question, guys? Did you get this example? Okay, let's have more example. Okay, let's go in another example. So number 7. So our given is 5 square root of 98 plus square root of 75 minus 2 square root of 48 plus 3 square root of 2. First, this given is we need to get the factors of 98. So the factors of 98 are rather, so 5 square root of 49 times 2 because 49 times 2 is 98. Plus, the factors of 75 are 25 times 3. And then minus 2, the factors of 48 are 16 times 3 plus 3 square root of 2 because 2 is the radicand, the last radicand in this part. Okay, so we have to square root. The number has a perfect square. So bring down 5 and then square root of 49 is 7. This is 7. Then square root of 2 is the radicand plus square root of 25 is 5. Then the radicand is square root of 3. Then minus 2 square root of 16 is 4. Then the radicand is 3. So square root of 3. And plus 3 square root of 2. So we need to multiply first the number outside of the radicand. So, so 5 times 7 is 35 square root of 2. Bring down 5 square root of 3. And then multiply 2 times 4 is 8 square root of 3. And bring down 3 square root of 2. So we have to combine the same radicand. So the same radicand here is the 35 square root of 2 and the 3 square root of 2. So we have to combine these. So 35 plus 3 is n, n pala, n. So we have 5 minus 8 square root of 3. Then we have to combine this. We got 38 square root of 2, the radicand, plus, or rather minus, because this is bigger than 5. So we have 5 minus 8 is negative 3. So that's why we have minus 3 square root of 3. So our final answer is 38 square root of 2 minus 3 square root of 3. Okay, did you get, guys? If you have any question, just comment on the box and ask me what is your question. So for our last example, this is our last example for this topic. So we have 5 square root of 4x plus 9, plus square root of 9x, sorry, minus 2 square root of 12 minus 3 square root of x. So we need to get the square root of 4 because 4 has a perfect square. So we have 5, then multiplying by the square root of 4 is 2. So 5 times 2 square root of x. The square root of 9 is 3. Then the radicand is square root of x. Then minus 2, the factors of 12 is 4 times 3. And then minus 3 square root of x. So we have to multiply 5 times 2 is 10 square root of x plus 3 square root of x. You just copy. And then square root of 4 is 2. So we have 2 times 2 square root of 3. And the last given is negative 3 or minus 3 square root of x. So we have to combine this square root of x. So we have 10 come from here. So we have 3 come from 3 square root of x. And minus 3 come from minus 3 square root of x. And then the radicand is square root of x. And then minus 2 times 2, this one is 2 times 2 is 4 square root of 3. Then we need to combine this. So the answer is 10 plus 3 minus 3. So we have to get 0 here. So we have 10 square root of x and bring down minus 4 square root of 3. So this is our final answer. Okay, guys, that is the addition and subtraction of radicals. For the generalization, you have remember this part. Only radicals with the same index, again, only radicals with the same index and radicand can be added or subtracted. So if you're having a and root of a plus b and root of a is equal to, you just add these two numbers, the whole number, a plus b, then the radical is n root of a. So we have the same n root of a. Or a n root of a minus b n root of a is equal to a minus b n root of a. You have to subtract the a and b, and then the radical is n root of a. Again, with the same index and with the same radicand, you can add and you can subtract. Okay, let's give a problem solving. So let us read, guys. Everybody. Joseph wants to know the perimeter of the table. This is the Joseph. So he is Joseph. The given length of the side of the square has square root of 10. So this is a square root of 10 feet long. So let us help Joseph to get the perimeter. How do we get the perimeter of the square? So our formula for the perimeter is you have to add all the sides. If you have 4 sides here, you need to add the square root of 10, square root of 10 plus square root of 10 plus square root of 10. Or for the shortcut, you just multiply by 4. So 4 square root of 10, you just multiply 4 into square root of 10. And that will be the answer. We have 4 square root of 10 feet because there's no factors in 10 that we having perfect square. So that is enough answer. So the answer is 4 square root of 10 feet. Okay, that's the answer. Okay, guys. Thank you for watching. God bless and stay safe. Bye.